Factoring polynomials. So we have the learning outcomes. First, identify and factor the greatest common factor of a polynomial. Second, factor a trinomial with leading coefficient 1. Third, factor by grouping. Fourth, factor a perfect square trinomial. Fifth, factor a difference of squares. Factor a sum and difference of cubes, and factor an expression with negative or fractional exponents. So what does it mean when you say factoring polynomials? So factoring polynomials is done in pretty much the same manner. We determine all the terms that were multiplied together to get the given polynomial. Another is factoring polynomial is expressing the polynomial as a product of two or more factors. It is somewhat the reverse process of multiplying. So we have the factoring basics. When we studied fractions, we learned that the greatest common factor, or the GCF, of two numbers is the largest number that divides evenly into both numbers. For instance, 4 is the GCF of 16 and 20 because it is the largest number that divides evenly into both 16 and 20. The GCF of polynomials works the same way. 4x is the GCF of 16x and 20x squared because it is the largest polynomial that divides evenly into both 16x and 20x squared. So we have the first general note, the greatest common factor. So how? Given a polynomial expression, factor out the greatest common factor. So first, identify the GCF of the coefficient. Second, identify the GCF of the variables. Third, combine to find the GCF of the expression. Fourth, determine what the GCF needs to be multiplied by to obtain each term in the expression. And fifth, write the factored expression as the product of the GCF and the sum of the terms you need to multiply by. So here are the example of factoring the greatest common factor. Given 6x cubed y cubed plus 45x squared y squared plus 21x. So solution, first find the GCF of the expression. The GCF of 6, 45 and 21 is 3. The GCF of x cubed, x squared and x is x. Note that the GCF of a set of expressions of the form xn will always be the lowest exponent. The GCF of y cubed, y squared, and y is y. So combine this to find the GCF of the polynomial term xy. So next, determine what the GCF needs to be multiplied by to obtain each term of the polynomial. So we find that 3xy multiplied to 2x squared y squared is equal to 6x cubed y cubed. And 3xy multiplied to 15xy is equal to 45x squared y squared. And last, 3xy multiplied to 7 is equal to 21xy. So finally, write the factored expression as the product of the GCF and the sum of the terms you needed to multiply by. So 3xy multiplied to 2x squared y squared plus 15xy plus 7. So analysis of the solution says that after factoring, we can check your work by multiplying. So use the distributive property to confirm that 3xy multiplied to 2xy plus 15xy plus 7 is equal to 6x cubed y cubed plus 45x squared y squared plus 21xy. So we have another general note. Factoring a trinomial with leading coefficient 1. So a trinomial of the form x squared plus p x plus c can be written in factored form as x plus p times x plus q, where pq is equal to c and p plus q is equal to b. So how? Given a trinomial of the form x squared plus bx plus c, factor it. So first, list factors of c. Second, find p and q, a pair of factors of c with the sum of b. And third, write the factored expression x plus p times x plus q. So example of factoring a trinomial with leading coefficient 1. So I have the given x squared plus 2x minus 15. And the solution is stated below. So next general note is factoring by grouping. To factor a trinomial of the form ax squared plus bx plus c by grouping, we find numbers with the product of ac and sum of b. We use these numbers to divide the x term into the sum of two terms and factor each portion of the expression separately, then factor out the GCF of the entire expression. So how? Given a trinomial in the form ax squared plus bx plus c, so factor by grouping. First is list factors of ac. Second, find p and q, a pair of factors of ac with the sum of b. Third, rewrite the original expression as ax squared plus px plus qx plus c. Fourth, pull out the GCF of ax squared plus px. Fifth, pull out the GCF of qx plus c. And last, factor out the GCF of the expression. So this is the example of factoring a trinomial by grouping, so the given 5x squared plus 7x minus 6 by grouping. So next, a general note of a perfect square trinomials. A perfect square trinomial can be written as the square of a binomial. A squared plus 2ab plus b squared is equal to a plus b squared. It is a trinomial that can be written as the square of a binomial. Recall that when a binomial is squared, the result is the square of the first term added to twice the product of the two terms and the square of the last term. So how? Given a perfect square trinomial, factor it into the square of a binomial. So first, confirm that the first and the last term are perfect squares. Second, confirm that the middle term is twice the product of AB. Third, write the factored form as a plus b squared. So example is given below. Another general note, differences of squares. A difference of squares can be rewritten as two factors containing the same terms but opposite signs. So a squared minus b squared is equal to a plus b times a minus b. A difference of squares is a perfect square subtracted from a perfect square. Recall that a difference of squares can be rewritten as factors containing the same terms but opposite signs because the middle terms cancel each other out when the two factors are multiplied. So how? Given a difference of squares, factor it into binomials. First, confirm that the first and the last are perfect squares. Second, write the factored form as a plus b times a minus b. The example of factoring a difference of squares is given below. Another general note, sum and difference of cubes. We can factor the sum of cubes as a cube plus b cube is equal to a plus b times a squared minus ab minus b squared. We can factor the difference of two cubes as a cube minus b cube is equal to a minus b times a squared plus ab plus b squared. So factoring the sum and difference of cubes. Now we will look at the two new special products, the sum and difference of cubes. So more explanation will be stated below. So how? Given a sum of cubes or difference of cubes, factor it. Confirm that the first and last term are cubes, a cube plus b cube or a cube minus b cube. So second, for a sum of cubes, write the factored form as a plus b times a squared minus ab plus b squared. For a difference of cubes, write the factored form as a minus b times a squared plus ab plus b squared. Examples of factoring a sum of cubes is given below. So key concepts. First is the greatest common factor, GCF, can be factored out of a polynomial. Check for a GCF should be the first step in any factoring problem. Second, trinomials with leading coefficient 1 can be factored by finding numbers that have a product of the third term and sum of the second term. Third, trinomials can be factored using a process called factoring by grouping. Fourth, perfect square trinomials and the difference of squares are special products that can be factored using equations. Fifth, the sum of cubes and the difference of cubes can be factored using equations. And last, polynomials containing fractional and negative exponent can be factored by pulling out a GCF. Facts about polynomials. Factoring polynomials involves breaking up a polynomial into simpler terms, the factors such that when the terms are multiplied together, they equal the original polynomial. Next, factoring helps solve complex equations so they are easier to work with. So the general guidelines for factoring polynomials. Check for common factors if the terms have common factors. Then factor out the greatest common factor or the GCF and look at the resulting polynomial factors to factor further. Second, determine the number of terms in the polynomial. A. Factor for terms polynomials by grouping. B. Factor trinomials or the three terms using trial and error or the AC method. C. Factor binomials or two terms using the following special products: difference of squares, sum of squares, difference of cubes, sum of cubes. And 3. Look for factors that can be factored further. And last, check by multiplying. And take note for this. If a binomial is both a difference of squares and a difference of cubes, then first factor it as a difference of squares and then as a sum on difference of cubes to obtain a more complete factorization. Not all polynomials with integer coefficient factor. When this is the case, we say that the polynomial is prime. So key takeaways. Use the polynomial type to determine the method used to factor it. It is a best practice to look for and factor out the greatest common factor or the GCF first. This will facilitate further factoring and simplify the process. Be sure to include the GCF as a factor in the final answer. Look for resulting factors to factor further. It is often the case that factoring requires more than one step. If a binomial can be considered as both a difference of squares and difference of cubes, then first factor it as a difference of squares. This results is more complete factorization. And this is the link for the topic, and I will end the discussion by saying that mathematics is not about numbers, equations, computations, or algorithms. It is about understanding by William Paul. So thank you for listening. I hope you have learned something.